Mikala Vashit Reddy, pursuing my BTech at the Institute of Aeronautical Engineering. Today, we are going to be discussing about a representation of semantic word embeddings based on SLDA and word-to-vector model. Usually, in natural language processing, essentially, converting a complex sentence into vectors is essential. This can be done through occurrence of multiple words or some of the methodologies try to use words as its base, targeted, especially targeted words, and they try to vector them. For example, in a sentence transformer, usually occurrence of words is pointed as one or two depending on the counter, and a matrix is formed. So today we are going to be discussing about that topic of word embeddings, but on a slight different note of methodology. So let's dive into this video. Yeah. So first, let us talk about how actually these word embeddings evolved during years and what are the challenges we try to essentially see when we try to convert a huge corpus of text into word embeddings. So text representations plays a pivotal role in performance of various natural language processing tasks like classification, clustering, retrieval, and automatic summarization. Traditional models like a bag of words and vector space models have been widely used due to their simplicity and effectiveness. However, these models suffer from critical limitations, including the curse of dimensionality, which is essentially a huge increase in dimensional spaces. Earlier days, this problem was tackled using a principal diagonal analysis. Now, due to higher efficient vectoring methods, PDI is mostly not used, but it is in use when it is primarily in use when there is an initial data and which needs to be converted into a process data at initial stages. To overcome these topic models like latent hmm, Dechallent allocation and its supervised version SLDA were introduced, which represent documents in a low dimensional topic space, capturing topic distribution. Further developments like Turney's vector space model of semantics improved semantic relevance measurement, but still lacked in handling word order and deeper context. Neural. So now we are going to talk about the proposed semantic representation model. Neural network based models such as Benchio neural probabilistic language model, word to vector and doc to vector, brought a breakthrough by learning dense low dimensional word embeddings. Yet word to vector assumes a semantic similarity based on word proximity, which does not hold true. Addressing these issues, the research authors have proposed a novel model called word topic to semantic vector. This model integrates global semantic knowledge from SLDA and local contextual information from word to vector. The semantic word vector of a word is formed by combining its topic ba- word topic based global embeddings with context based local semantics. Subsequently, document level semantic matrices called doc vector are generated. So let us see an brief overview of SLDA. Usually, SLDA stands for Supervised Latent Dechallent allocation model. Is a It is an extension of traditional latent digital allocation model that incorporates category labels of documents to improve the understanding of text semantics, while LDA models uh, help a relationship between documents, topics, and a word in an unsupervised way. SLDA introduces an additional layer by also modeling the relationship between topics and document categories. In SLDA, each document is assumed to be a mixture of topics, and each topic is a distribution over words. The SLDA, so now we are going to demonstrate how an inference is going to be happening in this type of allocation modeling. So, in supervised latent Dirichlet allocation model, uh, works by analyzing the words in documents, assigning them to hidden topics, and using the overall topic distribution to predict the document's category. During training, it learns how topics are distributed in different types of documents and how words are distributed within those topics. It updates its assumptions by comparing them with actual labels and reassigns topics to better align with the categories. This learning process helps SLDA to represent both the semantic structure of documents and discriminative information needed for classification. So, let us see a brief probabilistic graph about SLDA methodology. First, we are going to be inserting a raw text data, which is going to be pre-processed using a function k. Now, we will represent this as uh, phi of k, as you can see here. Now, alpha is usually a weighting function. This weighting function is used in activation function, which takes the preprocessed data as input and yields uh, z of mn, as you can see here. See what happens here is first the preprocessed data x of mn is inserted with z of mn, which is actually the result of the activation function to yield y of m. Now, this y of m is a probabilistic result of the SLDA method, as you can see here. And now, this y of m is again operated by gamma function, which is yielded through gamma method, and this y of m is crucial in allocation method. Now we will see in detail how these gamma functions are actually being formulated. Now this is the main formula in latent latent Dirichlet allocation model, where uh, probability of have probability of occurrence of z zi is equal to k conditions to um, x bar of I and y bar of I, um, and x is directly proportional to n k bar of I plus beta t by summation running from 1 to v n of k plus beta of u, which products to uh, the n of m and bar I plus alpha of k, which is the activation result of activation function, into n of k k n bar m plus gamma k. From this formula, we are going to be from this formula we are going to be deriving this formula, as you can see here. Probability of w of I conditions to w of j. There is no like uh, there is no cut between these two formulas. This is a simple probabilistic formula which yielded this one, as you can see here. So the result of these so the result 6 and 7 came from 1 when actually mathematically derived from, where this is actually the gamma part and this is actually the activation function part. Now, let us dive deep into the word topic to vector model. In the proposed model, the training document set is used to extract both local and global semantic information for each word. The local semantic embeddings of a word is learned using uh, the word to vector model, which captures how word is used within its surrounding context. Once both word-to-vector and SLDA have been trained, the semantic representation of each word is enriched by combining insights from both models, specifying specifically word-to-vector provides a context-based local perspective of word. See, this is actually old perception in natural language processing. Usually, to avoid one of the serious concerns like ambiguous and in order for artificial intelligence model or a natural language model to actually inference in our data, understanding context is very much important, and that is what this model does. Usually this model classifies all the data set into a separate topics. For let us say we have a river where we are going to be talking about especially catfishes. See, in water, so if we take water as a context, we specifically give in this model water as a separate word topic, fishes as a separate word topic, and catfishes as a separate word topic. As you can assume, this is basic assumptions I gave you, which help us to understand how word topic actually classifies things. This is usually done using classic probabilistic theories like Bayesian analysis and Manhattan analysis. Now, coming to actual working of the model, this is the raw data set as I have discussed earlier. Now, this this data set is divided into two, is given to two models. One is an supervised latent Dirichlet model and a word to vector model. Usually, word to vector model vectorizes all this data into a matrix form, whereas Dirichlet allocation usually divides the dataset into three entities: topic word, document topic, topic category, which is phi, theta, and phi, theta, and delta, as we have seen in a probabilistic model graph. Now, this SLDA is essentially the global semantic embeddings, which give us the C context, which give us the water context. Now, what word vector does is it gives us the actual catfish context, as I have been referring earlier. Now, these two embeddings are put together and to form a semantic word vector, which is actually um a combination of both global and local embeddings, which give a complete picture of the context. Now, to build a more effective semantic representation of a word, it is important to go beyond just using nearby context words. The word to topic to vector model addresses this by combining both global semantic information derived from topics and local context based information. To determine these similar words, SLDA uses the topic word distribution to calculate how likely certain words are to be semantically associated with a given word through their shared topics. In this model, wo- each word in a document is represented as a combined semantic vector. These vectors are stacked to form a matrix. This is a network image, as you can see here, and how global semantic vectors are actually being framed. Now, coming coming to results, The dataset taken is from mainly three resources: Sogua, Thug News, and 20 News, which are openly available in in online, where it it utilized as a training dataset and evaluate to propose word to vector model. Uh, in the word similarity task, the word to vector model demonstrates superior performance in identifying semantically related terms across word to vector and uh, word to word models, as you can see here. That's my point. Yeah. So, in conclusion, the word to vector model effectively combines local and global semantic information to enhance the representation of word meanings by integrating word to vector for capturing local contextual semantics and SLDA for global topic level semantics. Word to vector creates richer and more informative word embeddings. This dual approach addresses the limitations of traditional models that focus solely on either local or global semantics, enabling the resulting word vectors to better reflect both immediate context and broader thematic structure of a document corpus. So, thank you guys for listening to my lecture. I hope I will see you in next video.